Hi, and thanks for joining us for another VMware vCenter Configuration Manager demo overview or walkthrough. Today we're really pleased to have with us one of the PMs of the product, Becky Smith. Becky, thanks for joining us today. And today we're going to be running through some of the functionality associated with the Linux side of VCM, a little bit on kind of what we gather, what we collect, what we can display and show the customers, as well as the compliance that we can do from a Linux standpoint and patching. Does that sound about right, Becky?
That sounds great, and thanks for having me, Dave. So let's go ahead and get started. So we're logged in here into the VMware vCenter Configuration Manager. And as most of you are probably aware, the Configuration Manager, as Dave mentioned, does configuration management, patching, and compliance, as well as remediation for Windows, Linux, UNIX, and even VMware's hypervisor. Today we're going to focus specifically on the Linux side, but this is applicable to all the Linux and Unix platforms. So the functionality I go through today is the same across whether we're talking Solaris, HPUX, AIX, Red Hat, SUSE. So with this, one of the first things we like to start with is kind of our dashboard, because this gives you an overview of just all the Linux and Unix operating systems that are running in the environment. So this is a really nice way to just quickly be able to see how many Red Hat systems I've got in the environment, SUSE, again, Solaris and that, and then you can actually drill through. So we can look at our enterprise Linux servers here and see which ones we have and actually get some more detail about those systems. So you can see it's a Red Hat 4 ES server. It's got some Intel Xeon processors. And if we expand this, we can actually even see more detail about the different mount points and file systems that are on that server. And this is just to highlight kind of an overview report and dashboard, as I mentioned. So when you're in the console, the main points here are, this is where you can see the summary information about the environment, where you can actually see the raw configuration data for your Linux systems, how they're configured. And you can also see the changes that are in the environment. So not only do we gather all of this configuration data, but we also monitor changes on the data. So, our system's actually meant to be poll or schedule-based, so you determine what frequency you would like to gather this data across your different groups of systems. And then we will report changes between the last time we collected that information. And you can actually report and track that.
And maybe that's a good place to ask a question, Becky. How are we gathering this information?
So that's a great question. So the way we gather it on Linux, Unix, and Windows is we put some managed code out onto those systems. Some people would call it an agent, but it's very lightweight, and it actually doesn't run all the time. So the beautiful thing about our managed code is you don't have to worry about it taking up CPU and memory when it's really not in use. And the other nice thing is that we actually set a priority on our managed code when those processes do run. So on the Linux and Unix side, you set a nice value, and so basically our managed code runs runs at a very low priority, so it will never take resources from your actual applications and other services that may be running on those environments that serve your business. And so what happens is our main application server, where we've got a centralized SQL database, that's where we house all the data that we collect. That application server, we also call it our collector, will actually initiate the collection and say, hey, I need to gather this data from these systems. It'll then send the request down to that managed code on the managed systems, and then basically we can use inetd or xinetd to wake up our process, and then it'll actually go and gather and inspect the information. It keeps track of the last time it collected that data, so out on the managed node, we know what the data was the last time we asked for it. It'll then do a comparison and only send the changes, so it basically does a delta processing to say, okay, only send back to the collector what has changed in this data set since the last time we collected it. That then gets recorded up into our change management system, our actual change log, and you can actually see there's different ways to actually look at the change log data. So I can look at it by machine, I can look at it by specific data type, and what we mean by data type is these things here: machines, device drivers, disk, file system, IP processes. These are all data types in the VCM product, and it's just really a way for us to organize that data. but we're able to then track those changes. And so you can see in this case, something was deleted on NTFS directory permissions on this particular system. And so that's just an example. We also, in our changelog, keep track of any remediations that you run from VCM to those target systems, and you can see, what changes were made by VCM and which user in VCM actually made those changes. But we track both, so that's the beauty of the product when you take a look at this. And let me just right-click and show you. Anywhere in any of our data grids, we've got that nice feature where you can right-click and view cells. And so we can see that this was changed. This particular software provisioning package was changed, and it was changed by the VCM admin. And if it was available for rollback, we would see, that it was available for rollback, and you could actually roll back that change. So our change management, is very strong in that sense, as well as our change management allows customers to come in and set reconciliation types. So if they actually want to be able to use the changelog and determine, what changes were approved changes, in their change control process, which ones were kind of out-of-band changes or emergency changes that had to happen. And some changes in the environment may just be noise, right? I mean, the routing tables get updated. That's usually just noise in the system. It's not an actual change someone made to the environment. But you have a way here to say that. So if it was an approved change, you could actually put in your request for change number, and the tasks associated with that are marked as out-of-band. And so you can actually trend your good and bad citizens from a change management perspective and who's playing along.
So that's interesting. So we can track both the VCM initiated and the VCM non-initiated, or the rogue changes, if you will, because we've got that managed piece of code out there on the systems, and it wakes up when we tell it to, it checks for the changes, brings all the changes back, and it actually knows, hey, we made 25 changes to this machine last night, and by the way, only 20 of them were done and initiated through VCM through an official change process. There was 5 rogue changes, if you will, and I could kind of concentrate on those rogue changes and kind of start locking down my change process because of that.
Exactly. That's exactly right. And even beyond that, right? So you have that ability in VCM today, and you can go through and update this information and provide the reports on, the good, the planned and unplanned changes in the environment to your management. But even further, we actually have an integration that will integrate both with VMware's Service Manager and BMC's Remedy service desk solution, so that when you go to make a remediation change from VCM, like disable a service or change file permissions, or even larger, like deploy a patch, if you have that integration turned on, VCM will actually ask for what's the request for change number, what's the ticket number for this change, and it can create the ticket if the ticket doesn't exist, and then it will wait until that ticket gets approved in your service desk solution before it will actually run the remediation job in VCM. So there's a couple of ways to do that. So for example, if I want to schedule a patch deployment for midnight tonight, and I don't have a ticket yet, but I'm going to enter in my RFC number, it'll create the ticket for me. The job will get scheduled, but it'll be put into a pending state. So it needs to actually hear from the service desk that the ticket was approved. And if the ticket doesn't get approved by midnight, the patch deployment will not run. If it's an ad hoc change and I just want to say, okay, I just need, to disable this service, and I want to do it basically as soon as that ticket gets approved, then again, the job will get scheduled, kind of put into a pending state. As soon as it hears from the service desk that the job was approved, VCM will then kick off that change and actually go disable that service, and then it will report back to the service desk solution and say, look, job was successful, go ahead and close the ticket, the change is done. And so that's our closed loop CM process that we have. And again, that's both with VMware's own Service Manager and BMC's Remedy solution. So we've got multiple levels depending on how mature you are with your CM process in your organization.
That sounds very powerful. It certainly would help a change management process, or at least to help mature a change management process, to have that kind of control. Why don't we dig into some of the actual data that we're gathering, because I think there's some richness there that people will really enjoy and get a lot of value out of seeing.
Absolutely. So let's do that. So as we scroll down here in the console, you see that, again, we have multiple data types here. A lot of them expand into additional information. So we've got, kind of just the basic machine data. What's the OS version, kind of last reboot, what's the memory and processor, some kind of basic machine training data. We've got all the device drivers on the systems. We've got, deep disk information, so information about the hard drives, about the file systems, any quotas that may be configured, partitioned logical volumes, and even disk arrays. And so this really does cover the gamut of the different disk configurations available across Linux and Unix systems. Next, we've actually got syslog information. So we gather not only the syslog settings and how your syslog servers are configured, whether it's the old school syslog, whether it's the new syslog next generation, or the new syslog on some of the systems here. We gather those settings so you can actually see and ensure that your syslog settings are set up correctly, especially if you've got a centralized host and you're wanting to make sure that all your Linux systems are actually reporting to that same host. Is it set up correctly there? And here you can just see, the destinations that are going on and graphical, and then you can drill right into the data grid and see the raw configuration data, the subsystem, the severity, so we may want to check, whether the auth priv subsystem is actually configured appropriately. Is it, appending to the file? Where is it writing out to? And what kind of severity level is actually being reported by that subsystem? And one of the neat tricks I just showed you is in any of the VCM data grids anywhere in the product, we have this ability to column group where you can drag a column and you can drag multiple, and it gives you a way to quickly slice and dice the data and look into exactly how certain things are configured. So it's a really easy way for you to be able to organize the data to find something in particular, because we are dealing with a lot of configuration data. On Linux and Unix systems, we collect over 100,000 data attributes about those systems. So this ability to slice and dice the data becomes very key. We also have the ability to define kind of little filters right on this data grid. So I may want to just look at data for a particular machine, and I can quickly do that right here and apply this filter, and now the only data that I'm seeing, and you notice my column grouping holds, is about that particular system. That's just one way, and then I can turn off this filter. Those features are available throughout the product in any data grid you're looking at, whether you're looking at compliance results or patching results or just raw configuration data like we are right now. So if we continue to kind of move down the tree, we also get the syslog events. So any of the syslog messages that are actually being recorded to log files, we can gather. Now I want to make a clarification here. We do not actually listen on the syslog protocol, right? So we don't have an active listener listening on the syslog protocol. Instead, we go out to your syslog servers and gather all the messages that have been written out to log files.
Okay, so if we've got...
You can review them here.
So if we've got a piece of managed code, as we like to say it, on one of the syslog servers, we're going to pull back the syslog log files that have been gathered up on those syslog servers.
Exactly right. So in the syslog settings, it'll tell you which log files are being written out to and where they're located. And so our managed code is actually smart enough to look at the syslog settings on each syslog server and then go find those files and actually collect the messages out of those log files. Now, if the syslog is only reporting messages, if you've got it configured to only report messages to the console, to logged in users, then, we can't see those. So we can only get the ones that are actually written out to log file. But that is a best practice
Sure.
from a syslog perspective, that you're writing those out to a log file and that your admins are actually reviewing those log files on a regular basis. So one of the beauties of VCM is instead of them having to go out to every single syslog server itself and crack open those var ADM messages files and var log files. Instead, they can actually come into VCM and actually view their logs here. So they can actually do all that centralized, monitoring of the logs from VCM. Even further, they can set up alerts to say, if you see this syslog message come through, kick me off an email and notify me because it's something I need to come over and take care of right away. Or they could say, hey, send an SNMP trap to another system because I need this recorded and passed along. So there's also ways to set up alerts on the data that we gather, on compliance results, and on actual log data that we gather as well. And we get similar data from Windows systems and from the ESX hypervisors. But here's a quick view where I can see what are the top 10, syslog events that are occurring. Well, geez, SNMP is very chatty, right? And so is cron D, for example, on these systems. And then I can drill in specifically into these cron D messages and get a closer look at exactly what the messages are, which syslog servers they're being reported from, and who the host is, because this is the Syslog server, but the host could be a different system if you're doing any kind of centralized Syslog management. And then you can see here that cron is the one that actually reported it, and here's the particular message that, a session was actually closed for root. So that's an example there in our logging. File system is another really key area when you talk about Unix and Linux. File and directory permissions and ownerships is a very important thing to make sure you have locked down and hardened correctly. And so, this is an area where in the compliance, I'll actually show you there's significant amount of compliance rules against just file permissions and file ownership. Because as you guys know, Linux and Unix, everything's a file, right? So making sure that those file systems are locked down is extremely important. And so here you can see we've got some regular files. You can see their mode. So for our Linux guys, right, this is the shorthand mode of the actual spelled out permissions here. So 755 equates to rewrite execute for the owner of the file, read execute for the group, and read execute for everyone else who has access to that system.
So this is interesting because what we're looking at here is not just one machine. If you scroll all the way over to the left, this is multiple machines at the same time. So I'm actually looking at, so in the bin directory, the root bin directory, across my entire infrastructure, if you will, all of my Unix systems all at the same time. So I could kind of just say, what's installed or what do I have and what are the permissions across, for instance, awk, across all my different machines. That seems very powerful.
It's extremely powerful, and that's exactly what we give you here is the ability to just navigate the tree and then actually see across all of your systems that we've gathered this data from. This data is also available in a different slice. So that one was more by tree structure, right, of your directories and your in your environment. This one is just a list of files. So here I could just search for awk again. I could just do a quick search. And again, I just want to see the awk file across my entire environment, and this will actually do that as well. So you've got multiple ways to navigate the data, but again, seeing it across your entire enterprise in one glance. And then I can actually, kind of do a select all data rows, and I could even export this out, or I could copy it to a clipboard, right? So it'll actually export it out to an Excel CSV format that you could then use for something else if you needed to. You could write reports against this data, really rich graphical reports and detailed kind of data tabular reports on this information. So it is very powerful. And one of the other real powerful things about, our inspection of the file systems on the Unix and Linux side is not only do we get the permissions and the owner and group and size, we actually get you when it was last modified, last access, the last time any status information was changed. So whether that's the permissions or ownership may have been changed. We'll get the inode information, and if it's a symbolic link, which in this case it is, we'll actually tell you who that link is pointing to, right? So in user bin awk is actually a symbolic link to this Etsy alternatives awk, right? And then this is the key. We do file integrity checking too. So we will actually run a checksum on your Linux and Unix file systems and provide that information for you so you can write compliance rules against that, knowing that, hey, the value of this file should always be this. This is a critical file, that I want to make sure I'm watching the file integrity on, and I want to get notified anytime that checksum changes. And we can do that for you. Now, the beauty of this, too, is checksum is a more intensive operation to run. And so we're not going to run it on every single file, right, that we collect in your environment. So we've got some default filters set up for where we know are specific important files, like anything under Etsy is pretty important, and we'll run checksums on. But the customer can actually define their own collection filters, specify the path, how deep they want to go in that path, and whether or not they actually do want to do a file sum check and also a file type check. So in this case, the file type is just telling you it's a symbolic link, but in other files, it may be a 32-bit executable versus just an ASCII text file. And so we'll also get that depth of data for you as well. And so this is really powerful, as you said, when you think about the fact that I can see this information very quickly at a glance across hundreds of different systems. Yeah. And this view is not just Red Hat. This is across Red Hat, SUSE, Solaris, AIX, HPUX, again, all in one data grid, and the ability to do that quick slicing dicing that I showed you earlier. And then we also have remediations, right? So not only, again, are we collecting all this configuration data, but if the admin sees something looks like it may be misconfigured, let me go ahead and actually correct it. So in this case, maybe on user awk, I want to change the permissions and the ownership of this environment. And in this case, it's a particular file, so I don't need to worry about recursion. But you can see here, you can enter multiple file and directory paths, and you can actually say recursively make changes from this level to all the subfiles and subdirectories below it. Now I can pick which systems, right? So which systems do I want to make the change on? I'll just pick a few of those. And I want to do owner and group, right?
So I could have, for instance, used the column grouping functionality to find, let's say, a bunch of systems that had the wrong permission, and right from there, just kind of pull them into this wizard and just make the change right from within the wizard without having to log in all those systems, and then it gets tracked, and then I'll be able to see those changes up above?
Yes, absolutely. So here's where, let's go ahead and do this. We can enter a mode. So for the advanced Linux and Unix users, they can just enter in the 3 or 4 digit mode. If you do the 3 digit, then we assume a zero's in front, just like, change mod on the command line would do. Or if you're not as savvy with the mode, you can actually just say, okay, the user, this is the owner of the file. He should have all of them. Okay, the group should only have read, and the world, I don't want to have any. And then it's going to tell you effectively this is the permissions that are going to be set. So it's a 0740 is the actual code, and if you were to do the ls-la on the file system, you would see read, write, execute for the owner, the user, read for group, and nothing for everyone else on the system. And now I can just say I want to go ahead and run this now or schedule it sometime in the future, and it'll make that change on that file across all the systems we selected. And as you mentioned, in the data grid, I could actually pick multiple systems all at once to say these are the 5 I want to change, and then do the edit properties. And then you'll see all of those guys are listed, and further, let me just say permissions in this case. And then further, you'll see those systems are already pre-selected, but you can pick more. So you can also pick other systems if you didn't actually already have them selected in the data grid. And this behavior is the same across any of the remediations that we have in the product, whether we're talking, again, Linux, Unix, or Windows. So with that, let's kind of just do a quick, walkthrough. Let's keep going through some of the data, and then we'll jump over to patching and compliance. So you can see from an IP perspective, we get, several informations about just general IP configuration of your adapters and your interfaces, what domains, NIST domains, and DNS domains and gateways are set up in your environment. How are the interfaces actually configured? So are they DHCP or not? Is it disabled? What subnets they may be using? And in all these cases, these are just nice summary reports, but you can drill through on them, or you can just click View Data Grid, and it's going to take you again to that raw list of the data grid of all the information. And as you mentioned again, this is interface information across all of your Unix and Linux systems in one pane. And I can do the column grouping, and I can take a look at this data. So routing and ARP and open ports information we also gather. From a processes perspective, we will get the active running processes on the environment, and we've got multiple ways to slice and dice them, by name, by machine, or just the whole list. We'll also get the open files information. And on Mac, we get the launch control processes and their limits. From a system initialization perspective, we're going to gather your boot parameters, your kernel parameters, and all your startup scripts. So you can actually quickly see by init level. So let's say, run level 5 is Linux, is multi-user with the GUI. What's everything that's set up to start or stop, in this environment, right? So you can see here's all your kill scripts, and you can see all your start scripts.
Holy cow! Coming from a Unix background, that would have been nice to be able to have this data available to me instead of having to log out of each box to see which was going to start up and which was going to miss starting up things that I expected to start at each run level.
Exactly right, and you can actually do a define. So if you were looking for a specific script, right, I just want to see, let's go right here. So the script is like, and then I can do %signs for wildcard cups. I just want to see cups as a printing service, right? So where is that set up? Okay, well on these systems it's set up to actually kill it and stop it and run level 5, right? But on these other systems it's actually set up to start. I've got some inconsistency there, and I need to look into that and kind of figure out, should I change that, right? Are my environments configured consistently for what services and daemons should be started or stopped at what run level? So it's extremely powerful. And like you said, this is something that takes a long time and can be tedious to do manually, even with your own script to gather this information. And kernel parameters is another really powerful piece, right? So do I have my kernel parameters configured appropriately across my systems? And again, this is all Unix and Linux systems that we manage. Going into dynamic services, right? So what do I have set up for inetd, inetd, right? So I can see again at a glance here how many are set up that are internal versus not, that are enabled or disabled. Again, I can go right into the data grid, and I can do my own filtering to say, okay, I want to look at service state, okay, and I want to group by service state. So in this case, these are stopped, and in this case, these are running network services. So at the stop services, I just want to see what's not running, right? And then my other option here, too, is my startup type. So what's not running, but what should be running, right? So these are not running today, but they're actually configured to be enabled, and they should be running. So why is that? Why are all these services not running when their configuration as they should be? Did an administrator accidentally go in and shut the service down? I could go look at the change log and try to figure that out and see what happened. I can also just go back onto the system and start these. So we also get cron, so all the cron jobs and cron settings you may have set up. So again, you can make sure that you've got consistency across your cron jobs on all of your Linux systems, and also your RPC settings, so your remote procedure calls. So this is basically for services that are not well known, right? So in network, in NTP and that, these are all your well-known services: FTP, shell, telnet, SSH. But then there's a bunch of I guess that's the right way to say it, services that aren't as well known and don't have a defined and consistent port and protocol that's used, and that's your RPC stuff. So we get that, and that's a lot of depth of data here as well, right? So my port mappers and a lot of my other things going on, how are they configured? Are they talking on the right ports and programs with the right protocols? UDP, should that even be set up, right? Maybe you want to make sure you don't have any of the UDP because we know it's insecure. One of our other really big values here is that not only do we get all this configuration data that I'm walking you through, but we also have the ability to parse well-formatted files on any Unix and Linux systems, bring them back into our database, and they're available to the changelog, to reporting and compliance, just like all of our other standard data types. And so this is a great extension for our professional services team to be able to go out and collect custom configuration data on Linux servers and bring it back and get all the power of VCM, that reporting and compliance again. We gather the software inventory, so what packages and utilities are installed in the environment. You can look at them by machine, by name, by OS, or just all of them in one large grid. And so again, here you can see, here's my top 10 installed packages. Right, and I can see the quantities here, how many of them, and then I can drill into that data. But software inventory is also an important thing because, in a lot of environments, especially with Linux systems, if you take the default OS install, you get a lot of extra things installed that you probably don't care that much about. And so, let me see, do I have software set up here that I actually don't want set up? And I could even then write a compliance rule to say, hey, make sure this software package never exists. And if it does, the system's non-compliant. And then you can use our remote commands capability to actually write a script to do the remediation if you want.
So again, this is packages across the entire, if you will, Unix, Linux infrastructure, right?
That's correct. And I could even filter this view to just look at Red Hat, for example, if I wanted to, right? So this will just show me, okay, just for Red Hat Enterprise server, what are the top 10? And so you can see there. Here they are. And so that does give you a good idea of your software inventory. And again, from a configuration and compliance perspective, there are cases where you just may not, want some additional packages installed. It's bloating your file system. They're not necessary. Or you really don't want them on the system because you don't want users to be able to utilize,
Sure.
Those actual packages, right?
Sure. Or I found a package that just isn't safe for what I would consider best practices in my environment, so I can at least chase those down now because I've been able to look at across the entire infrastructure.
That's correct. And we do find several customers who, have kind of a blacklist of packages that are not allowed in the environment. And so that's an important thing. Again, you can see that data quickly here, but then you can also go over to compliance and write a rule so that every time you're checking to make sure that package is not installed across your environment. And I'll get over there in just a minute. There's just more things I want to show you.
I was just going to ask that same question, but I didn't want to drag us into compliance quite yet.
Yeah, so we'll go there in just a second, and that's why I'm kind of going through this data in a little bit of depth, because I'm basically teasing up use cases that make sense to just look at from a configuration management perspective, but become very important from am I configured to my own internal standards, to regulatory guidance that's out there, to industry best practices, and so then I can actually write compliance rules and monitor that. But you can also always just come over here into the console and dive into the current configuration state of your environment and take a look. Okay, so now if we get down into security, we get local users and groups information, some patching and NFS information as well. And so that kind of concludes the richness of data that we go after. Let's go over to the patching slider and actually take a look at our patching capabilities. So on Red Hat, we've got patch content for any of the deemed security-related patches, and also just Red Hat recommended type of patches. So we're not going to be able here to assess against any RPM in the environment, but only the RPMs that are really deemed critical to the OS, from a security perspective and a recommended perspective. So right here you can actually quickly see that we've got bulletins for different versions of Red Hat, different architectures, the actual bulletin name from Red Hat Network. And again, if I right-click here, we can actually view the row cells and see the additional information. So the detail about the OSs that this patch pertains to, the default options for installing this patch when you actually go to deploy it, and then the distribution type and any information. We can also see the real detail of the bulletin and information that's actually provided from Red Hat. So what is this bulletin all about? Well, in this case, it's actually fixing a bug with Open LDAP, for example, and it gives you the details about, should I reboot or not? By default, this patch will not reboot, and it doesn't say that I need to actually force a reboot on this particular package. Even further, we've got the link to Red Hat Network to actually go onto Red Hat's network and see the detail and even further information about this bulletin beyond what we have here in our UI. And then you can see which OSs are affected. Now, as you probably know with Linux is different from UNIX and Windows systems in the way they do patching. In Linux, you don't get a separate bundle or zip file of files and binaries that need to be laid down, and they're called XYZ patch. In Linux, they actually provide a whole new version of the RPM package that is the patch, right? I mean, it includes the patch. So in that case, the packages and the patches are one and the same when it comes to Linux, where in Windows and Unix are actually different. And so here's where I can see all the bulletins that are available for me to assess my environment against. Then down here, I can actually drill into my assessment results, and I can see assessment results for all the bulletins, or I can actually just look for a specific bulletin, and again, I can do my searching here, and I can now quickly see that on this particular system, this Red Hat bulletin, the patch is not needed, right? So I really don't need to do anything. No action is required because it's not a bulletin or a patch that I care about or need to do anything about. Here's another one. So in this case, on this Red Hat system, and if I had more, you'd see all the Red Hat systems listed here again where this bulletin is applicable. And my patch status here is I'm not patched. And if you take a look at it, there's no severity rating from Red Hat about this particular patch, but it is one they're recommending, and we're saying you do need to take action on that. You should probably go ahead and install this patch. So from right here, I can deploy the patch either up there in the toolbar or right-click and deploy. Let's walk through what a deployment of a patch would look like. Now in this case, it's going to pre-select this bulletin and this system for me. Okay, but I can also pick additional systems and additional patches. So you see here, I can actually pick more patches than just the one I had selected and say, you know what? I want to deploy all of these patches, and I want to make sure to include any prerequisite patches that are needed for these. Now, if I move over to the next screen, I'm actually going to have the ability to say, what order do I want these things deployed in? So this one, actually, I want to move up, and I want it to be the second patch that's deployed, okay, on that particular system. Now, I have the option. I can just go ahead and patch in the regular run level the system's currently in, which is usually just multi-user mode, right? Or I can actually say, you know what, these are kernel patches, and I feel much safer and better if I actually install these patches in single user mode. And so what VCM will actually do is it will take the system down into single user mode, deploy the patch, and then bring the system back up into regular user mode. So let's take a look at what that looks like. So I'm going to install this in single user mode. You know what? The command line options for installing that RPM is what I want to use, but I could overwrite that right here if I wanted to. And then further, I can actually do a pre and post script around the patch. So let's say, for example, you've got important applications or services running, and you want to actually make sure they're taken down cleanly before I actually go and actually deploy the patch. So if you had any remote commands already previously defined in the system, they're available here for you to actually select and pick those. And the remote commands you can actually define up in the console. I know I didn't show you that, but that's where they're at. And then you actually have the option with both these remote commands. Do you want to run them at the current level, or do you want to run them in the run level that the patch is actually being deployed at? So you could even run scripts in single user mode, for example, or run these, and what will actually happen is it'll run the remote command in multi-user mode, take down the service, for example, then switch to single user mode, install the patch, come back up to regular user mode, and if you had a post-deployment remote command that said, okay, now go restart those services will come back up. And effectively now, we have patched the system successfully and brought it back up to its running state as it was before we started the patching process. So that's extremely powerful. And with the deployment, you can run it now or schedule it for the future. You can also set up, if you're not going to go into single user mode, right, and you can still do the command line options and the reboot, but then you also get the option here again to run this now or not. And then I can also do separate reboot scheduling. So do I want to do a reboot after the patch is deployed? Do not reboot or reboot immediately after the patch installation, or reboot at a later time. So the nice thing here is I can actually schedule reboots separate of the patch deployment if I need to. Again, depending on the use of the environment, when your maintenance windows may be, when it's okay to do this patching. And when the reboot occurs, you also get the option to specify messages to any users who may be logged in, to gracefully terminate processes. You can also do a reconfiguration reboot, and this is important for certain kernel patches that we can deploy, that you have to reconfigure the kernel in order for that patch to actually take effect. And then you can also delay the reboot, so you can send the message and then still delay it, by 2 minutes to try to, again, give users time to log off the system if they happen to be on. And so that's our patching capability from a Linux and Unix perspective. As I showed you, this is kind of all the results. You do have the ability to also create templates and say, look, I want to create a specific critical patch template for just the critical patches that I care about, because I want to see the results just for that set. And so right here, I can just pick the particular Red Hat patches that I deem critical to my environment, that I want to see those results independent of all the other assessment results in the environment. So if we click on this, now that we've made that assessment template, we'll actually get to see the results just for those particular bulletins across our Red Hat systems. So here you can see a nice overall machine patch status assessment level, right? And you can see which machine is actually current and up to date, and one of the Red Hat systems is, and two of our other Red Hat systems are actually not fully patched. If we scroll down, you can actually see a little bit further breakdown of the asset classification. So how important are these Red Hat systems to my organization? And then the actual criticality and severity of the bulletins themselves. So, the big concern here is I've got one vital server that's actually missing one critical patch. And so I want to drill through and see that specifically, and here it is, and I can see that. And now I can go ahead and deploy, but you can also see that we recommend that, hey, there is a superseding patch for this. And so if you want to get more up to date, we actually recommend that you install the superseding patch that's listed right here. So that kind of concludes our Linux patching capabilities. And with that, we'll actually move over to compliance. Were there any other questions around patching?
Yeah, actually, just where does the content come from? I mean, are we pulling this all directly from, in this case, Red Hat? Or if I'm a VCM user, where is this kind of getting collected for me, I guess?
So that is actually a great question. So we've got SLAs in place for how quickly we have to have the content, the patch content available once the OS vendor actually publishes it. And then VMware has actually got a website where this patch content is available. So that the application server for VCM, aka the collector, generally needs internet access. That's the easiest way to do it. And it will actually automatically check for new patch content that's available on the VMware website every 8 hours. The customer can actually change that setting and and increase or decrease that frequency, as well as you can manually at any time check for updates to see, hey, are there any new bulletins available? Now, if for some reason your collector doesn't have internet access capability, that's okay. You can actually still download that patch content and then get it over to the collector server, and then we can actually load them from a local file, and you see that option here. So that's how you get the patch content available to be able to do the assessment to understand what patches are or are not installed on your Red Hat systems.
Okay, great.
Okay, so with that, let's jump over to compliance. So I know when we were in the console and talking about a lot of the configuration data, I gave some examples of different things that you may want to actually have a compliance rule for. So the way that our compliance offering works is you've got rule groups, and within rule groups is where you're going to define rules and filters. And as you can see, we have a lot here. And let me actually expand this so you can get a better look at all of the content. Now, what I'm showing you here are all of the rules available from an internal group within VMware called the Center for Policy and Compliance. And their job is really to go out and analyze and review the different industry and vendor and regulatory guidance that's out there on how your Windows, Linux, UNIX, and even your hypervisors should be configured. So this is just the content that we provide, and the beautiful thing about our compliance content is it doesn't ship baked into the product. So it's not like you have to wait for the next product release to get new compliance content for guidance that's out there in the industry. So our compliance content can actually be imported into any running, VCM system that you have, and now you've got the information available, the collection filters that go along with that compliance content to ensure you're collecting the right data to be able to do the compliance assessment, and you get all the rules and that available, and you can start assessing right away. So that's really the power. And on this system, I have a lot of that content loaded, so you can see we've got all kinds of antivirus and best practices and ISO for Windows and for Linux and Unix. We've got the Center for Internet Security benchmarks, so you can see here again, across the different systems, even some Oracle RMDBMS checks and configurations. We also have things for, Active Directory and some other, kind of core infrastructure applications on the server.
So where is this content coming from then?
So this content actually comes from a group in VMware that will actually write the compliance rules for VCM from this external guidance. So like, for example, the Center for Internet Security's benchmark, those are just PDF documents that describe, prescriptively what you should be checking, how the environment should be configured, around internet security and kind of hardening those different, operating environments. And then, like I said, either you can go to the website and download the content and then just import it into the product. We also have what we call is a content wizard that you can actually run, again, on the application server for VCM, and it'll go out to the internet, see what packages are available, compare them to the ones that you already have loaded into your database, and then it will just give you the option to download and import new ones that are available that you may not already have. And so the nice thing is you get the flexibility to pick what compliance content you want to use. And the other real powerful thing is when we look at all this compliance content, as a user, a lot of our customers have their own internal policies and standards. They may have, standards for how a Windows server or Linux server should be configured. They may have internal security policies. And what they can do is actually take, for example, here, if we go to Center for Internet Security in the Red Hat, if we look at the rules here, they can actually take and copy and clone these rules and make their own internal compliance compliance rule group and template and policy for their thing, but they don't have to write all those rules from scratch. They can, but they can also reuse all of this rich content that we already provide. And that's what we find a lot of our customers do, is they will take the content and then they will edit it, tweak it, or copy or clone it to meet their internal policy, because it may be a little stronger than the industry guidance, or maybe even a little weaker, just depending on what data point we're talking about.
So this is interesting. It looks like the rule names correspond directly with the CIS requirements.
They sure do. So if we actually pop one of these up, not only the rule name are we giving you the specific section, in the CIS benchmark for it, but here's the description from the CIS guide, right? And then we actually tell you this is a specific version of the benchmark, and we give you a link to that benchmark. So you can actually link out directly to it and open it up off of CIS's website.
So I don't need to be an expert on CIS, but I can just download the new content and then kind of right from here understand what each of the rules are doing and determine if the rule's ready to go out of the box, or if I just need to do a quick tweak to it then.
Absolutely. Yep, very easy to do. And so this is where the rules are defined. So what we're looking at right here is how the rules are defined. As I talked to you about in the console, right, the data types. You can actually see which data type. Here's file system, right, that's being used, cron. This is inetd stuff, and so you can quickly see what data is being evaluated, against in this set. And again, the slicing and dicing that I showed before, the column grouping, all of that's available in this view as well, in all of these data grids.
That's great. So can you show me how we actually run a compliance, would we call it an assessment?
Yes, and a compliance assessment. I will absolutely do that. There's one more thing I want to cover, though, before we jump over to assessment.
Sure.
When you're defining the rules, it's also very important to define filters for the types of systems that should be evaluated against this rule set. The reason that's important is you can actually combine multiple of these rule groups together into one compliance template that can be assessed all at the same time. And the power of that is I could have a comprehensive Linux template that was actually running my Red Hat rule group and my SUSE rule group, and my Debian rule group underneath that, but I can run that all as one compliance assessment. And the power of the filters is for each rule group, it's going to say this filter is going to define what systems to run the rules against. So you don't get any false positives, right? Because the last thing you want to do is run a Red Hat rule against a Windows system, because it's always going to be non-compliant or fail. And so that's where the power of the filters is. So in this case, you can see this filter is saying only run these rules against OS name, Red Hat, Enterprise Linux, and version 5. Any 5.0, 1.2, any of that, but version 5. And so this is very specific, because there are sometimes cases where the specific compliance rule and how you evaluate it can differ even between versions of the same operating system. So with that, let's jump to your next question of how do I do an assessment. And again, you can see just the amount of data, NERC, lots of Microsoft stuff, operational, PCI, and regulatory, DISA, NIST guidelines that are out there. So if we go to templates, templates is where you actually assign those rule groups to a template to say, this is what I want to assess. And in this particular case, we're going to look at the DISA guidance on Red Hat. And the reason I want to show you DISA is it's actually the basis for several other compliance templates we have for regulatory compliance. So if you look at, let's say, SOX or GLBA or HIPAA or FISMA, none of those regulatory guidances provide prescriptive technical controls on how your IT system should be configured. They are much more oriented around people, process, and other things. Now, what they do say is make sure your IT systems, are configured in accordance with industry best practices and security hardening guides that are out there. And so the DISA organization in the U.S. federal government and the NIST organization actually deliver these security technical implementation guides as well as checklists that are very prescriptive on how a Red Hat system should be configured, how a Solaris system should be configured. And so we use that rule set as actually the basis for our SOX and our FISMA and our HIPAA content, because again, those regulatory guidance don't give their own prescriptive technical controls like PCI would. A PCI is actually a case where it gives you that prescriptive guidance as well as the people process guidance and requirements. And so, like I said, the DISA checklists are actually really solid and strong and a good case for SOX. But a customer could come in and say, you know what, for SOX, I actually would rather use the Center for Internet Security's benchmark rule set. Fine. They can go in and edit that template and say, don't use the DISA rule group for Red Hat, use the Center for Internet Security's benchmark for Red Hat, or use my own internal rules that I built for Red Hat for SOX, for example.
That makes sense.
Yeah, and it's really powerful, and that's why we separate the two. So compliance, in VCM, think of compliance templates as just the policies. I mean, that's all it is. It's just a container of the rules, and when you run assessments here, these are the results you see. So what I'm showing you right now is the compliance results from me running the DISA Red Hat Linux controls. And you can see that 14 machines were assessed. A total of 145,000 different conditions for the configuration of those Red Hat systems were evaluated. And those 145,000 conditions are within 164 actual rules, because our rules do allow you to define multiple conditions to check as part of one rule, which is very powerful and very necessary for a lot of the guidance that's out there. And so what you can see here is overall, I don't have a single Red Hat system that is passing all of the rules for this template, for this policy. But this breakdown, like I showed you in patching, is very similar in compliance, where I can now see, again, by the criticality, by the classification of my assets, my vital servers versus, my average ones that aren't that important. And again, by rule severity. And rule severity is, again, from that external guidance, how they describe the criticality of each of the rules. So with DISA, there are rules that are considered critical, important, moderate, and low. From an administrative perspective, on my average servers and low severity for the rule, I'm not going to be that concerned about these 61 failures down here, because they aren't critical rules and they're not on critical assets to my organization. Instead, I'm going to focus on these 7,000 right here that are failing and drill into those details. So let's look at just my vital servers that are failing just critical rules for DISA. And this will now drill into the data grid and give us really that depth and richness of data to show us the detail of the assessment results and why in particular these systems are failing those conditions. So you can see right here, I'm only seeing non-compliant results, right? So it's already pre-filtered. I can turn this off, by the way, too, because all I've done is predefine a filter and drill through. I can turn that off and see the full results across all systems. But let's just take an example here in case, and let's just, again, look at the row instead of scrolling. So on this particular Red Hat system, who is classified as vital and the rule severity is critical, what rule am I actually failing? Well, from the DISA guideline, version 5, release 1.15, home directory file permissions, I'm actually failing this rule. So it's a conditional file system check. And it's basically looking at, all the different files under your home directory. And it found one particular file here where the read for the world, other read bit, right, so that's the worldwide readable bit, it's expected to be set to 0. It's actually set to 1. So that means this home directory on this particular file is actually available for anybody who has access to that system to be able to open that file. And again, the DISA guideline says for home directory file permissions, the world should not have read permissions to your home directory. Okay, so here's the detail you can see, and you can actually see the date it was run and what user ran the assessment. I could rerun an assessment again, so I could say, you know what, I want to go ahead and look at this information again. Let me go ahead and rerun an assessment. I can add an exception. So I could say, look, you know what, this particular system in this rule, I've already got an exception that's been approved, and I don't want this thing to show up as non-compliant for the next 3 months because I've got an exception, and I can basically, I don't have to fix it until 3 months down the road. So I can give descriptions and information. I can actually type in my sponsor who approved this exception. and then I can actually select which template that I want the exception to be for. So I want it to be for my DISA Red Hat. Controls, oops, I picked IBM, sorry. Okay. And then I can even also set the exception for an entire group of machines, or just a subset. So in this case, I'm just going to go with these Red Hat servers that I want the exception defined for. And now I can pick, how do I want the exception to work? Do I want to override non-compliant results and make them compliant until this exception expires? In other cases, there's customers who actually want to overwrite compliant and flag it as non-compliant. Now that's a more rare case.
So if I do this, these won't show up on, if I do it the way it's set up now for overwrite non-compliant results to compliant, I'm not going to be alerted to, or I don't have to worry about these showing up on the report, let's say, for the next 3 months until the exception expires, and then again I have to, once again, tackle that issue.
Absolutely. So right now I can say, look, I want this exception to expire in September. And any assessment run after that date, it's going to show back up as non-compliant. But between now and then, every assessment, every report you run, this will show as compliant for you.
Great.
The next thing that you can actually do from here is, we've talked about remediation before. So you can do ad hoc remediations via the console on that, disable a service, change file permissions just because you see something out of whack, as well as you can actually set up compliance to automatically enforce, where possible, those non-compliant results. So there are a lot of things that we're checking, and we can't remediate all of them, but we can remediate a good portion. And so when you actually go to run the assessment, you can say, I want to go ahead and auto-enforce. So as soon as that assessment runs, any rule that it finds that is non-compliant, that is available to enforcement, VCM will automatically schedule or kick off the job to enforce that and make that compliant on your target. For some customers, they don't want the auto-enforcement to happen because their change management process, they may need to get approval. So they first want to just be able to report on the non-compliance and then get approval to actually remediate the non-compliance. So they can later come in and right-click, or from the top menu, pick Enforce. And from here, they can pick which systems and which items. So do you want to enforce all items that are available based on this current compliance run, just the item I've got selected in the data grid, or actually be able to filter it even further? And then what's going to happen is our engine will actually look at everything that you picked and determine which out of those non-compliant items we can actually enforce. So in this case, I picked one that I can enforce, but you get the gist of it. It'll tell you, here are the things that are enforced. It'll actually check that you have permission in VCM to remediate that and to enforce it. And then you'll see the actual jobs and things that will be submitted in that case.
And then it goes through the normal closed-loop change management process if I've got that initiated.
Absolutely. So if I set up Enforce and I actually have the integration with the service desk set up, when I click Enforce, it's going to ask me for my request for change and my ticket number. It'll go to see if that ticket's approved before it actually will run the job. And if the ticket never gets approved, the enforcement will never run. It'll just sit in our pending queue. And then if the ticket gets approved, we run the enforcement, and then again, VCM goes back and closes the ticket, says job was successful, and it's done. And this is all, again, still recorded in VCM's change log as well. So you can even see what user ran the enforcement, when they ran it, against which systems.
Well, that's great. First of all, thanks, Becky, for the time today. I think that helps everybody understand a lot more of what we can do in the Linux environment with regards to just being able to view data, being able to make changes and control your Linux environment or your Unix environment, being able to patch, and of course, finally, and probably most importantly, being able to ensure compliance across your Linux Unix environment. Any last things to say, or any things that we may have left out?
That's really it. So again, I thank everyone for your time. I hope this was a good overview and understanding for you of our Linux and Unix capabilities from a vCenter Configuration Manager perspective.